This is a apical four-chamber view. All chambers are dilated, mildly dilated, moderate to severe concentric left ventricular hypertrophy. In this image, this left ventricle, the left ventricle has got concentric hypertrophy. All chambers are dilated. You see, left atrium, left ventricle, right atrium, right ventricle, all are mildly dilated. Important point is to note in this cases that this is only 16 years old boy who is having systolic blood pressure 200 and diastolic blood pressure 100 and a severely raised high blood pressure. So I thought to interrogate renal artery. So I got fibromuscular dysplasia of right and left renal artery. The characteristic finding in ultrasound examination you see. So that is why I have taken this case for a study. I will show you all that image. Again, you see the same thing, concentric LVS, LV prominent size, ejection fraction is lower normal side. You see, this is the image of right renal artery. You can see the beaded appearance. You can see the beaded appearance. Beaded appearance means what? Let's see. A string of pulse. So you can see that in this image clearly, this part is aneurysmal, this part is aneurysmal, this is aneurysmal. So this renal artery is aneurysmal. At the same time, you can see the velocity scale is 154 centimeter per second. So velocity scale is very high. Still it shows turbulence here. You can see the highest velocity is here localized in this part. So this is the case of renal artery stenosis due to fibromuscular dysplasia. Though common in female patient, but this child has got this fibromuscular dysplasia of right and left renal artery both. Right has got more severity compared to left side. Just want to show you the highlight window. This is beaded appearance. You can see the beaded appearance. That is usually seen on CT scan, the DSA, digital subtraction angiography. That is clearly seen, but I have seen this case on echocardiography. You can see the image. You can see easily the beaded appearance. You can see the beaded appearance. That is the important point to show you. This beaded appearance. You can see the beaded appearance. That is very interesting finding. That is why I have taken this case for you to show you the beaded appearance. This is the part which is the most flow is most turbulent. Only 16 years old boy is having this picture. Blood pressure, systolic blood pressure is 200 and diastolic is around 100 at the time of examination. Again, you see the same image. You can see the beaded appearance. You can see the beaded appearance. So renal artery stenosis due to fibromuscular dysplasia. Most common cause of renal artery stenosis in young patient. More common in female compared to male, but this case is male. Interesting part is the beaded appearance. How I have got this type of image? Only because I have increased the velocity scale up to 140 centimeter per second. But normally in case of renal artery, velocity scale is quite low, less than 40 centimeter per second, but I have increased it to 154 centimeters. You can see this velocity scale here. Then I have got this beaded appearance. Image is quite clear. Again, you can see the same thing. Same thing. Renal artery begin being red in color because close towards the probe, then goes away from probe, so blue in color. Red in color because towards the probe, blue in color away from probe. Your direction of renal artery is in this way. That is first part towards the probe, last part away from the probe. So blue in the color. So this is the case of fibromuscular dysplasia causing severe hypertension, urgency. This is, you see again the concentric LVS, apical forcible view, low normal systolic function, 16 years old boy. You can see the same thing. Parasternal long axis view, concentric LVS. You see the velocity across right, 330 centimeter per second. More than 180 centimeter per second is abnormal. In this case, 333 centimeter per second. So very abnormal. Formula wise, if the velocity of renal artery is more than 3.5 times compared to abdominal aorta at that position, abdominal aorta at the renal location, that is indication of significant renal artery stenosis. But in this case, the velocity is 333 centimeter per second. You can see easily in this image. This is flow across right renal artery. This is flow across left renal artery. The velocity is here 318 centimeter per second. So that is also very high. You can see this is right renal artery. This is again the velocity right renal artery in this view 471 centimeter per second. You can see the turbulence. Velocity scale is 67 centimeter per second. Up to 67, you see. This is velocity scale. Now you see 67 centimeter. Here you can see the highly turbulent area in this zone, indicating stenosis. You can see the velocity. Velocity is quite high. So this is the case of secondary hypertension due to renal artery stenosis due to fibromuscular dysplasia and period appearance of renal artery indicate fibromuscular dysplasia. Very interesting case. You can see the period appearance. This is period appearance. Thank you.